thermocouples. So remember when we're measuring temperature, there are several different ways to measure temperature on our instruments. One is with a bimetal thermometer, which basically means we have two different metals fused together. One expands at a rate, I'm going to do it this way. One expands at a rate faster than the other and will move an indicator, right? So that's a bimetal thermometer. A thermocouple has two different types of metal that are fused together at one end of the connection. And if it's a super high temperature, like in turbines, they're going to be super expensive metals, right? So what kind of metals do we do for super high temperatures? Chromel and alumel. That sounds cool. Chrome. Her favorite color is chrome. Anybody know that Trace Adkins song? Yeah, that's a good song. So chrome's expensive and alumel, yeah. If it's not a super high temperature, then it would be constant tan with either iron or copper. So you will have constant tan, then iron or copper. So quick review is you don't cut those wires shorter. Now, the problem is we've moved up in the world and we've managed to figure out how to make adjustments and stuff. But when they wrote the FAA books, when they wrote the FAA textbooks, for the most part, you would never cut the wire shorter. If you had extra wire, you'd just spool it up and secure it, because that wire that's coming back, one's usually going to be copper or constant tan. The resistance of them is very, very important. We're not making much voltage. We're talking millivolts that we're making. So if we're only making millivolts and then we send it through wires, if we change the resistance of that wire at all, the indication that you're going to get for how much voltage is actually reaching the gauge is going to change. Because we're not really, I'm going to use the word powering anything with the voltage, right? We're powering a little magnet to do our thing. So these are terrible voltage generators as far as making useful voltage, but they work for indicating temperature. So changing the wire length at all is a big no-no, and the FAA wants you to know that. Now, we get into the 21st century, especially after 2010 or so, and a lot of our thermocouples, we can start to change wire lengths and stuff. And the wire's not constant in iron, but your written questions are going to say don't change them. If you ever see terminals that are like actually fixed together like this with screws, that should be one big indication. Don't ever change those wire lengths. The reason it's a crazy heavy duty connection is to make sure that there's basically 0 ohms resistance there, right? If you just had like a stake-on connection or a Molex, and you're like, well, how many ohms of resistance are there? Well, maybe I got 3 milliohms. Well, with thermocouples, we want like pretty much no resistance, so we'll bolt the wires together to make sure, man, I got like no resistance there. You catch that flash too?
Yeah.
Weird. All right. So that's thermocouples. Just wanted to touch on them a little bit. We'll get into them deeper in power plant. Yeah, we got to talk about it a little bit. So when we get to, say, turbine engines, we'll talk about how we can put a bunch of them in parallel. And we covered this Monday, but quick review. They're going to average that voltage. It'll often go through that amplifier before it goes to your gauge. But we'll deal with that much more in power plant. But there might be a question on the exam about cutting the wire going through the thermocouple. Don't do it, right? Questions, comments? Is that basically making sense for everybody? Okay. Okay, got that taken care of. My son, and I actually corrected this slide because, well, actually he's doing a lot better about it, but he used to, when you gave him a job, he was getting really good at not quite finishing. And have you all heard the statement, practice makes perfect? Somebody tweaked it for me, practice makes permanent. Practice makes permanent. Because if you practice something wrong, like when I was in basketball, I always used to shoot from over here, right? And I'd practice a lot. It didn't make me perfect, but now I have a really hard time, instead of shooting up here like you're supposed to, I still shoot from my ear. So practice makes permanent. And the reason I say that is, as you guys are working through practiced up at not being done with your classes, it's gonna be hard to break that habit. So start practicing being on speed. My son was practicing not finishing things. He got so good at it that I was thinking about giving him a black belt in it. We were gonna give him a black belt in martial arts. So I did add to the end. He's actually doing a lot better. So I'm gonna have to put somebody else's name in there now. So don't be the guy that gets their name on here for next year for the students. You don't want to be that guy, right? You don't want to be that guy. There is a proverb that says, even a child is known by his actions for whether his conduct is good and right. Even a child is known by it. So you guys are building yourselves a reputation. Make sure you're building a good one. All right, we're going to do a little bit with vacuum systems today, and that's where the Venturis come in. And then we're going to shift over to warning systems for instruments. I could do this one for a month, warning systems. It's so fun. Basically, when you're learning to fly airplanes, when you go up into a new aircraft that you're flying, probably 30% of what you're learning is the new warning systems, is how to read them and how to react when they go off. So we're going to cover it in half a lecture today. Way more info there, but we're just going to cover a couple of them so you're somewhat familiar with them. So you're vaguely familiar with it. Oh, yeah.
I gotta find a new seat.
Vacuum, you might have to. Vacuum systems, we're going to deal with Venturis. Venturis we can change pressure with. When I wrote this slide, I was so proud of myself. I went through and I found a slide that the air on the inlet was a different pressure than the air on the outlet. Can you guys all see that? It's very difficult to find a Venturi slide that has those different. They're almost always drawn so that the air on the inlet is the same as the air on the outlet. And that's not accurate, but they leave it one level low. So I was proud of myself for finding this, and then I realized it's still a bad picture. Because if you actually did this, and here's where if we were gonna, instead of do Venturis, if we made one of these that we could blow the leaf blower through, it would really, it'd make my day. So maybe I should add that to the extra work slide. But where should that water level be in all reality? Yeah, they're saying level, but actually there's some ram error problems going on here. It's actually going to be down below, right? Because it's going to be a higher pressure than the air around it, because you've got that ram air effect going. I'm 99.9% sure, but whenever they draw these pictures, they don't take that into account. So even with the good pressure picture, it's not great. This one is probably the best picture I could find. It doesn't give us water levels, but the highest pressure is at the inlet of our Venturi. The lowest pressure is in the very throat of our Venturi, and it's back to high pressure on the backside again, but it's slightly lower than here because, well, he's not experiencing the ram air effect anymore, right? If anything, the rest of the air coming out here is kind of like grabbing him by the hand saying, come on, let's go, come along with me, which lowers the pressure in the tail of our Venturi slightly. Do you like that? You like that voice? Come on. No. Okay, so our Venturi, the main thing you gotta know for this class is where's the lowest pressure? The lowest pressure is in the throat of the Venturi, right? Now, if I wanted to do some work, if I wanted to do some work with those air pressures, because, well, if I can point out, I've got two different air pressures, a smart guy would be like, why don't I use that to do some work? I'll do the high pressure and I'll push it through something and let it come out the low pressure side and I can do work with that, right? So you would say, what two points would I want to pick if I was going to do some work with this? Just kind of logically. We kind of identified 4 different places, right? We've got 1, 2, 3, and, well, just the environment. So what, Randall?
Well, logically, probably the center of
Yeah, it's probably gonna be lowest pressure in the environment. Now on this picture, if we actually drew it right, if that's actually the highest pressure, it would be the center and then the high. So the reason we don't do that on our aircraft though is if we have a hose or if we have a tube and we start moving a flow through it, there's friction, there's resistance, right? And what we have found in aviation is basically if I take a Venturi and I hook up two hoses to it, I hook one up to the lowest pressure, and then I run another one, so lowest pressure all the way to the cockpit through my instruments. If I run another hose all the way back out to the high pressure section, whatever I gained by running the hose out from my high pressure wasn't enough for what I lost having that air come through a tube all the way back up here. So they basically said, you know what, we'll just do the cockpit of the aircraft as our environment, as our high pressure. So our cockpit of the aircraft is our high pressure, it's our environment. It's pretty much the same as static, right? In a perfect world, it's a little bit lower, but they're saying if we added a tube to that, they go cockpit of the aircraft is the high pressure, so the air is going to get pushed from the cockpit, through a filter, through an instrument, back out into the lowest pressure point, so the air gets sucked into the Venturi, out into the airstream of the airplane. Randall's looking at me like,
I'm just wondering, in some cases, is the static port just used for the environment?
no, because our static port, what's the definition of static? We don't have air moving. If we started introducing moving air and changing pressures, our altimeters, they're not gonna like that at all. So we're gonna keep our vacuum system separate from our static system. Actually, a great question, because I just tweaked your exam, trying to confuse you with a very similar. I was like, I took a part that was confusing and I'm like, okay, I'll make it totally false for people that aren't paying attention in class on Monday. So great question, Randall, great question. Did I see a hand over here?
Yeah, I was just making sure. What did you tweak?
A question.
Shit, you telling us. Yeah. Which one? Just trying to cover the base there.
All right, so back to, Bernoulli's principle is the air has to accelerate to get through the Venturi, that accelerated air. If you want to go really deep, what we did is we changed the pressure that's on there, the PSI A. We changed some of the pressure to a kinetic energy as it is accelerated because now it has an inertia. It's moving faster. Once it slows back down on the backside here, we will reconvert that inertia, that kinetic energy, back into potential energy, which is pressure. So we go from a lower pressure back up to a higher pressure after we slow the air back down. So that's instrument class 200, but I'm not supposed to teach at 200 level. It's instrument class 100 level. But that's why we have the lowest pressure there, is the air's been accelerated. Yeah?
I could be explaining something. Why are we using Venturi when we have a vacuum that is powered that is drawing air to the system?
Great question. This is a Venturi picture on an aircraft. Does that look like a new picture to you?
Like a what better?
New. Is that a new? No. Once we came up with vacuum pumps, we kind of took these Venturis and we're like, wow, I don't really want to fly my aircraft at 250 mile an hour with this big thing that makes drag. So Venturis were basically what aircraft had, I'm going to use the word before vacuum pumps, or cheap airplanes before vacuum pumps. Vacuum pumps, great, they're expensive. So they figured out with zero moving parts, I can create an air pressure that I can do work with my instruments. So the early ones, they were like, wow, Venturi. And I think actually you probably had a vacuum pump really early and they found out they're very unreliable. So they were like, a guy's like, I can do that with a Venturi. And then the airplanes got faster and faster and they're like, that Venturi's a lot of drag. Let's go back to a vacuum pump and make it better. So yeah, old airplanes is where you will see Venturis. Old, slow airplanes. That's the general idea. Old, slow airplanes.
It's hard too because your instruments then wouldn't be spooling up.
Oh, you're taking all my slides. Are you reading ahead?
No.
Yeah. So in a couple slides we'll talk about if you're sitting on the ground, you're not getting any vacuum pressure, right? They're designed for when you're moving 100 mile an hour. Now it works. So, okay, here's a picture of it, and here's our central air filter. And I brought in some air filters here to show you. These are air filters, right? But those are filters for our relief valves in our vacuum system. So relief valve air filters. Here's some air filters. These would be considered more of our central air filter, typically mounted behind the instrument panel. It's going to draw in cabin air, suck through these filters, and then go through their instruments. This is an air filter as well, a bracket air filter. This one's what your engine uses to draw air through before it burns it, right? So if you said the aircraft's air filter, there's a little bit of where you got to go, well, hold on a minute. We got lots of air filters. Which air filter are you talking? Are you talking the vacuum system air filter, or the vacuum system relief valve air filter, or the engine's air filter? So the only reason I brought that up is making sure we've got multiple air filters, so know what environment you're in when people are talking to you about the air filter, right? All right, so it comes in through the central air filter, you could say the vacuum system air filter, through that instrument, through our gyro in this instance, and then out through the venturi. Now, this one does not give us a, and I see that hand, Job, I'm almost there. This one does not give us a relief valve in the picture. Depending on how fast we're driving and whatnot, if our gyros are sensitive to overpressurization, some of these systems will actually have a relief valve built into them as well. So they might have a relief valve that looks just like the ones, I'm just gonna grab one, that looks just like the ones on our vacuum system. So if the vacuum pressure is too low, that word low and high is tricky, right? Too low, too high, we'll cover that in another slide. If our pressure is too low, they would say, wow, you're working too good, I'm gonna allow a little extra air to come in here, and basically it's gonna reduce the amount of vacuum that our venturi can make, because if these could make unlimited amount of pressure at 5 inches, we'd have like, somebody'd make a lot of money on the infinity machine, right? Well, they can only handle so much airflow. So if I bleed a little bit of air in here, now the capacity of this thing's being eaten up by my relief valve. So some of these even have relief valves that will keep my suction from becoming too much suction. Okay, Joe.
Using this Venturi system seems really nice for like reliability reasons, but does it offer, is it susceptible to scale errors?
So,
as in like 50 to 100 to 150 knots, like are we gonna see scale errors in all of our vacuum instruments?
so most of our vacuum instruments we're gonna run off are gyros. So all we're doing is spinning a gyro up. So if the suction were to get too high, we're typically gonna have a relief valve that says we're not gonna allow you to get too high. So it's a too low problem. So if you're flying too slow, yes, your gyro might not be working as well if you're flying too slow. They're designed so that if you're in the air, hopefully you're going fast enough that it runs your instruments. The problem is, like we talked about, if you were trying to take off through the clouds, well, it's not going to run your gyro until after you get up to however many mile per hour, and then you still have a certain amount of time that that pressure is going to take to spool up. So they're not a reliable source for, let's say, flying IFR, can I phrase it that way? But a lot of your instruments, a lot of our airplane, they're going to have an electric one, and they're going to have a pneumatic one, right, a vacuum. So depending on which one you make which, there's options, but pretty typical on these are gonna be a directional gyro and a artificial horizon. If you can't figure out which way's up on takeoff, you shouldn't be flying that day with a Venturi. And if you're sitting on the runway labeled 280 and you can't figure out which way is 280, probably shouldn't be flying that day either. So they do rely on getting going before everything spins up. All right, so inside our gyros, sorry, not gyros, inside our Venturis, and I'm gonna pass a few of these around, one for you. I could've just grabbed all three, I guess. Venturi inside a Venturi. We like double layer these. They're pretty cool that way. Some of the images aren't the greatest, but you got one Venturi, which is the big one on the outside, and you'd say, hey, this is the tightest point of it, right? But what they often do is they put a secondary, oh, I hope I didn't use that word wrong. It's in a slide or two. Yes, secondary Venturi. Secondary is the proper term. The secondary Venturi is that guy right there that is on the inside of it. That secondary Venturi, the tail of it, is typically pretty close to the tightest part of the primary Venturi. So basically what you're doing is you're saying, hey, if here's my primary Venturi and this is the lowest pressure, I'm going to give myself another Venturi that if we said, well, what's the lowest pressure in this Venturi? You go, well, we know it's lowest in the neck of it compared to the other pressures. And because we put this, and they're kind of assuming the inlet and the outlet's the same pressure, because that's what people do when they design these things, they are saying, hey, this part is the lowest point in our whole system. So that's where the air gets discharged, is into the smallest area of the secondary Venturi, right? So what that does for us is it's kind of like a Venturi inside a Venturi. It works pretty cool. Gives us a good low pressure. They make these things in various different sizes. What's kind of interesting, I guess just mathematically, is if you have a 2-inch diameter Venturi, which is that what these are? These might be hard to tell. That's a 4-inch. I think that's a 4-inch. They make them smaller. They make a little 2-inch one. A 2-inch one will typically give you 2 inches mercury vacuum at flight speed, which is kind of cool. So some of our instruments, like our turn and slip indicator, they only need 2 inches. It's only a one hinge, if you will, gyro. They don't use much pressure. So you can run a turn and slip, the old ones, off 2 inches, and they'll just have a small one. Some of our bigger gyros, picture our attitude indicators, especially old ones, right? It's a bigger, it moves more ways, they take more suction to run them. Both the attitude indicator and heading indicator, they're bigger, heavier duty gyros. Those are gonna require typically 4 inches or so. So, if you make a 4-inch Venturi, you get about 4 inches of suction. That's kinda cool. It starts to break down after that, like a 6-inch one. I think you get about 6, but an 8-inch one, you get about 6. It's just, you get a higher volume. Plus, I mean, at 100 mile an hour, you start getting, that's a lot of drag. So on the one hand, you're going, I got free pressure difference. And I'm like, that is not free. That's a lot of drag on the aircraft, especially at a high speed, which is why we eventually go away from them. But most of them only have one tube, like we talked about. It's just, we want the lowest pressure possible. You can stumble across some of them that have 2 connections to hook them up. And I almost want to say, nope, I don't want to lie to you. I was going to say, I almost want to say where the pipes are. One goes into the Venturi, and then the other one is just grabbing the ram air. Not that one. So, for what it's worth, what's weird is they give us this picture in the FAA textbook. I've got one Venturi creating probably 4 or 5 inches of vacuum. So it'll run these ones without a problem. And basically, they got a needle valve. Notice it doesn't say a regulator or a relief valve. They're just like, we're gonna pinch off the airflow a little bit. We're gonna basically say, we're pinching off your straw. And it's like, oh, when you do that, I get less pressure when I'm trying to run. So it's, yeah, back to kind of Job's question. I think it was Job's question. We're not real worried about accuracy. We just want suction to spin a gyro, right? Suction regulator. Oh, this is one of the images that I go, don't call it a regulator, because regulators technically, according to case Visser, would look at the pressure leaving them, right? Because the air is going that way. The reason they call it a regulator here is it's regulating the suction pressure. So this is one of the instances, right? Why'd they do that to me? That should be called a suction relief valve. It should be one's got the picture with a small one and a big one. Notice turning banks on the small one, heading indicator, attitude indicator is on the big one. And HI, okay, we got a heading indicator. That's what we said we were gonna call them from now on. Pressure gauge obviously is going to be measuring what is sucking onto our instrument. So if we have a pressure gauge, it's going to be reading the pressure sucking onto the instrument. And I think this is the relief valve on that one. It's just not labeled. All right, let's see. We'll go with Matthew first and then back to Ward.
So I didn't understand what you were saying the secondary venturi is for. Is that just to increase the pressure difference?
Yeah, it gives us, yeah, it's basically a way to make it work a little better. Yep. And if you say, hey, how come it's not perfectly in the middle, like choke down? If you're like a mathematics guy and you want to do a ton of math, because the body of it, like we're going to draw it cross-sectionally, because the body of it takes up some room, and you look at the ones in your hand, by the time you get to the choked off point, you're getting really close to kind of where the thing sticks out. So yeah, they're slightly ahead of the part, but that secondary venturi, the discharge of it is getting really close to that most choked down part. But yeah, the secondary is the small one in the middle. I'm sure somewhere somebody called them the other way around. Part of that is I think I mislabeled them last time I had the PowerPoint written. And then I had to go back in and be like, okay, where does it say it most of the time in all your prep work questions? If there's on a prep work question, they're going to call the secondary the small one in the middle, for what it's worth. All right, Mr. Ward.
So the pressure gauge is in PSIG,
Maybe.
but it's not absolute pressure.
It's probably in inches mercury.
Inches, yeah, sure,
Yeah.
inches of mercury. So then, isn't 6 inches of mercury less suction than,
Let me see if I have one that shows the pressure gauge. Let me go back, suction gauge. Of course we don't. It might pop up later. It's going to depend on it's the same as, these operate at basically the same pressure as your vacuum pump is, which what you said at 5.3 inches? I think it's inches. So 5.3, they're operating very close. So 4-inch ones like 4 to 5, the
so that's
relief
like
valve.
negative.
It is a
Negative.
yeah, it is a negative, and the way I'd rather call it is it's a pressure difference.
Gotcha.
The difference in pressure from the cabin to the middle of that venturi is 4.5 inches water column. But yeah, the venturi itself is a negative pressure. We are absolutely not forcing air into the venturi in a ram air force to go through the instruments. The air is going from the cabin through the filter back out to that low pressure point in your venturi, which is wild to me because if I was designing it, I would have just like put a scoop like a pitot tube and been like positive pressure. But apparently venturis are slightly more efficient than ram air. Well, I guess. T.
For the suction gauge, does the turn and slip indicator not have a suction gauge?
Often not.
Why? Does it not
Costs
need
money.
it?
And they weigh something.
But the
Yeah.
other two do need it. They're more important, is that the?
I'd say they're more important.
Is that,
That's the idea, yeah. Pretty much. All of them will have a flag. Yeah, all of them will have a flag to tell you if they're not running fast enough to run, right? They'll put a flag on it like, hey, I'm not working, don't trust me. So maybe on an instrument like this, you might view, I don't know if I necessarily need a gauge, because if there's no flags, my pressure must be good.
unless flag broke.
But it's unless the flag broke, but yeah. We're back into that, let's say, gray area. All right, there's my different pressures that I already talked about. New gyros, I'm gonna call it, new, want those higher pressures, where back in the day, they might have only had this guy on a gyro in your aircraft, and they could get away with that little 2-inch just fine. New gyros, a lot of times they don't even need as much pressure, like you run on a vacuum pump, they'll run on less. The idea being manufacturing, can I say got better? They made it so, we can run off less pressure. We'll let you get away with it. Alright, what is missing from these pictures? Anybody? We'll say like this one.
That one.
The pressure gauge filter?
Filter. I should have called that Amanda. Thank you, Amanda. Were you gonna say filtered? I could tell. She was filtering.
Actually sensitive.
She was filtering her answer. She's like, I should raise my hand. But I didn't ask for a hand raise, so good job. Yeah, filtered. Any of these are gonna have a filter. So if we were gonna draw a filter in, right, we gotta have a filter. I don't know, it looks like that. And then we're gonna come to each of them from our filter. Okay, everybody following with us? So good. Yeah, we wouldn't wanna suck dirty air into our instruments. Okay, where we go? Small picture, bunch of different style filters. Grandpa, is it Grandpa doesn't have a filter? I think it's Grandpa. Were you working on Grandpa, Tiki? So it has like kind of the bottom plate that a filter would get bolted on, but the filter is missing. So if you're doing instruments in, I think it's Grandpa, 172. The 172. So if you're following hoses in the 172, you're gonna eventually get to basically a bracket like this in a fitting, but the filter itself is not on there. Any filter is gonna have a way to usually replace it, right? A lot of times if we're filtering air, you're not gonna clean it out. Now sometimes if you're filtering air, you can clean it, but what they decide, especially with engine air filters, is they're like, you know what, let's put a bunch of oil on there so the dirt particles stick to it, and then it's almost impossible to clean it. So the 172 just has a thing like this hanging down with a hose off it. The filter is gone, but super easy to replace, right? So whether it's an annual item or a as-needed item, they're pretty easy to replace. So we're not gonna talk a whole lot about filters because you should be able to figure that out. Dirt comes in one side and doesn't go out the other. Okay. There's a complete picture with an air filter. That one kind of looks like my engine air filter, but it's not. It's not, right? Different air filter. Alright, if we had a vacuum pump, and that's what we went to now, we got rid of our Venturi, we're leaving Venturis behind because only crazy people would fly with a Venturi, right, Randall? Yeah, something like that. We're leaving Venturis behind because we want our gyros to work while we're sitting on the taxiway, getting ready to take off through the clouds. So now we have a vacuum pump. Some of the early vacuum pumps, they were lubricated with oil. We talked about that a little bit when we talked about pumps. So they would put a little bit of engine oil into this vacuum pump. Oil. Well, if we're putting a little bit in, that might mean it's gonna, mist a little bit out. So that oil coming out of the vacuum pump is gonna go into an oil separator. That's what this thing is, right there. Pretty fancy, huh? We'll pass it around just for fun, but mainly it keeps your guy next to you awake. No, I shouldn't say what you should do if he's sleeping. So the air comes in with oil in it, and basically it'll have stuff on the inside, but the oil will settle to the bottom, and there'll be a tube that usually just goes back into the engine crank. Because coming out of the vacuum pump, that's basically pressurized slightly, right? Your vacuum pump's like, I'm pushing air. So it'll push the pressurized oil back into the engine. Now, it's not like we have to say, we're never gonna put any air through this line. No, we don't really care. As long as you're dumping it into the crankcase, mostly oil, but if we ever get where the oil level is not like, I'm oil, so we push a little bit of air into the crankcase. Who cares, right? Don't care about the crankcase. What we want to make sure we're not talking, though, is that the vast amount of cubic foot per minute is going to be, this is terrible, is going to be coming out our air one, right? That'll work. The vast amount cubic foot per minute is coming out the air, and that's got to go somewhere. Now, if this is an oil system, are we going to put that in our de-icing boots? No, we wouldn't want to get, right? Even after an oil separator, we'd be like, yeah, I'm not risking it. I'm not going to get oil in my de-icing boots. But whether it's oil or not, typically we're just going to dump this in the engine compartment. Now, our engine compartment, you'll learn later, has baffles, and if you're above the cylinders, it's a little bit higher pressure because the air has to get forced down across the cylinders to cool them. Down below the cylinders is usually a little bit lower pressure, and it's actually kind of getting drawn out or sucked out So the most common place to dump that air from your vacuum pump is gonna be, I'm gonna call it under the cylinders, but the way it works on airplanes, we'll draw one. There we go, with a propeller, and you got your engine here, and then there's an air baffle plate. So the air is gonna come in and go down across the engine and out. Everybody tracking with me? So they will dump the vacuum pressure anywhere in one of these areas. It's the low pressure side. Now, Prepware might like to use the word slipstream. If we were gonna look in a 172, the sheet metal kind of from the main cowl to the back, it's not airtight, and the hot air that you just warmed up because it went across the engine is gonna go down and it's gonna leak out the bottom. So we're basically taking our air coming out of our oil separator, just dumping it in that engine compartment, and it goes out into the slipstream. So whether you say it goes into the engine compartment or it goes into the slipstream, same thing. Making sense? Okay, good. I would recommend making sure you basically have this picture, well, that you could draw it up. Like if you said, okay, I got a filter, and then I've got my instruments, and then I've got my pressure relief valve, and then I got my vacuum pump, and then I may or may not have an air separator, and then it's gonna go somewhere else. Because if I said, hey, tell me where the air goes, and you start off with, well, it starts in the slipstream and then goes through the oil separator, through the vacuum pump, out to my instruments, you're thinking about things backwards, and you will get that 5-point question wrong on the exam. All right, vacuum pumps. We got wet pumps, we got dry pumps. Most of you guys took apart, in our pump class, you took apart vacuum pumps, right? There weren't actually hydraulic pumps when we did a vane pump. So you guys are fairly familiar with vane pumps. Air's coming in, it gets trapped in an area. That area gets bigger, and then it gets smaller, and it has to go somewhere. Some of them are oil lubricated, that'd be a wet pump. Some of them are dry, there's no oil that lubricates them. They're just usually like a carbon or a graphite vein that slowly wears out over time. Talked about that already. Here's an old picture with the same kind of thing. I was supposed to cover, if you were grabbing on the prop and you're turning it backwards because you're working on the aircraft, you're gonna turn this vacuum pump backwards, right? Which means you could theoretically pressurize up your instruments, which they're never gonna wanna see pressure coming backwards. So some of these systems will have a check valve to keep us from pressurizing our instruments up. In a really rare situation, if you had a kickback on startup or something go wrong with our pressures, you could pressurize up. But that's the only reason there's a check valve, is it basically keeps anything from our engine side from ever accidentally reverse pressurizing our gyros or instruments. Not necessarily need it. Selector cock is just saying, hey, if I had 2 engines with 2 vacuum pumps, which one am I running? And this one is interesting. Suction relief valve. Wouldn't our pressure relief make it, if the suction gets too high, to not happen? Well, what if I am turning the engine backwards, trying to pressurize this up, but this check valve closes? Ooh, I don't want to over-pressurize my suction system. And the closest I can tell from all my research when they show a suction relief valve is that suction relief valve labeled that way. When we also have a pressure relief, it's like which one is which. One of them will keep that from getting too high a pressure if we turn the engine backwards. The other one is regulating our suction pressure. So drawn in, we might be able to figure out which one's which, but there might be a relief doing both things. One sets the vacuum pressure, the other is a safety in case we essentially turn things backwards and the pressure gets too high. All right, so true or false, the pressure relief opens when the pressure gets above set point. This is a tricky question, right? What would you guys say? Show of hands for true. All right, show of hands for false. this one. I would call that a false, for the reason being, if we're talking our main relief, which typically we're gonna be a suction relief at that point, or a vacuum system relief. It's if the pressure gets below set point, if it's too much suction, and I'm totally gonna admit, that is a tricky, dirty question.
But that pressure relief is a little bit higher.
Yeah, I don't like the question.
It's still before the pump, so it's
So-
still suction.
If you see the question, if it's labeled that
That's the
way,
answer to the question.
I believe the answer is false.
You can argue that suction gauge is in positive numbers. So
Suction gauge is in positive numbers, so you could say, well, if it gets too hot, yeah, you could. I don't like the question.
I see.
If I was boss, I would strike the question from any they ever ask you. But I do believe, and actually I'm gonna double check my notes to make sure, because I just looked at the exam today. But if you got that, if it's a pressure relief, it would probably be true. If it's a suction relief, it would be false. So I would put it in your head that way and hope we're right. Pressure relief, true. Suction relief, false. And I'm gonna check the exam. But yeah, it's a tricky question. Grant?
Is there a reason the suction gauge is connected to the attitude indicator?
So our suction from our vacuum pump is gonna be the same pressure all the way back to here, right? So, where am I at? This, you can assume, is the same pressure inside that. It's giving you 2 ports. Some of our instruments, you'll see that on the back of the attitude indicator. You have 3 ports on them. Let's see if I can find one. Here we go. Add one. Some of them will have 3 ports on them. I know I passed around one the other day that had it. There we go. I've got an air inlet, and one of them will be an air outlet, and one of them will just be connected basically to the same pressure point. So this and this are the same pressure point. So, good question. It is a little tricky on that drawing, isn't it? T.
Mr. Dino's saying that it had the 2 for accuracy, because if it only had 1, if something happened, there'd be no indication that suction was bad.
Yeah, so your suction gauge always has to read 2 pressures. Our knee-jerk reaction would be, I just need the vacuum pump compared to my cabin, right? But if my air filter were to get plugged up, and we were checking the suction compared to the cabin, I might show a good suction from my suction to the cabin, but if my air filter's plugged up, I might not have any pressure difference from in and out of my actual instrument. So the reason there's 2 hoses is we want to look at very specifically what's coming into the instrument and what's going out of the instrument. That's what our suction gauge reads. So it doesn't read cabin pressure, it reads the pressure the instruments are seeing, which is after the air filter. Okay.
Which case?
Yes.
She said that question will not be open more than same.
It will be, and I believe it's false, and I'll double check that and get before the exam tomorrow as well. It's a tricky question. The way it's labeled is the relief valve on the exam, which I think I copied the prep work question, is talking suction relief valve. So it'll say true or false, the suction relief valve opens if the pressure gets too high. And to make it true, you'd have to say the suction relief valve opens if the pressure gets too low. It's a tricky, so, yeah.
Was this a question, you said this was also a prep work question?
I put it on the exam because it's prep. Where do you find it?
Okay. I don't think it's still the prep work.
Oh, they might have got rid of it? That'd be nice. Might just be a free one for you then. Alright, that was a terrible picture, but one review. Vacuum pump discharges to either the engine compartment or the slipstream, depending on how they label it and who they are. Alright. We got a couple more vacuum pump things, and then we'll take a break before we get to indicator systems. Vacuum pumps. talked about them a bunch. Rapco makes a specific one. They got that little port and they got this little tool on here. So if you take the little port off, ooh, it's usually on there. Oh, there we go. Tighter than finger tight, but I did it for you. You can take this tool, you can move the little indicator down to the end. You're gonna basically push it into the hole and hopefully you hit the main block. And basically the little line that's on here disappeared. That means, oh, okay, I must have gone far enough in. And then I'm gonna rotate either with the prop, which is scary if the tool is in here, but you're gonna rotate it so that it drops down into where the vein is, right? You notice it drop further, and I pull it back out. Now, as long as I can see the proof mark, that proves I dropped down into the vein. And as long as the little piece is not bottomed out on my tool, the vein is long enough. So as that vein wears down, you would basically be able to stick the tool further in. Once those come in contact with each other, now my veins are wore out and I need a new either vein, but realistically vacuum pump, you send it in for repair. So I'll pass this around the room if you want to test the veins. That one does test good. By doing that, as a reminder, some IFR planes will want you to change the vacuum pump every 500 hours. If you're not flying IFR, or even sometimes if you are, they'll just say as needed when the pump goes bad, and there's no way to tell how close you are to bad. SMAT was averaging about 1,000 hours, 1,000 to 1,200 hours, so I think we're averaging 1,200. So some people will just say, you know what, every 1,000 hours of engine run, I'm gonna replace my vacuum pump. So this is only one brand vacuum pump. It became the most popular. Wonder why, huh? Pretty smart. I can actually check when it's bad. But it's a little tool that if you have a Rapco, you can say, hey, is my vacuum pump getting close to where I should replace this thing or not? Did I see a hand?
Where does the vacuum pump discharge again?
Either in the engine compartment or into the slipstream, depending on how you look at it.
Okay.
The air in the engine compartment will eventually be in the slipstream,
Right.
so we,
You just need to leave somewhere.
yeah, exactly.
Thank
And
you.
the oil is just circulating from the sump through the pump back to the sump.
From the oil in the engine, probably the high pressure oil, to my vacuum pump metered really small amount, and then out through the oil separator back into.
And it's enough that it's worth it to save the oil.
Yeah, because otherwise after, 200 hours of running,
Yeah.
plus if you're dumping it overboard, like, your airplane's gonna get dirty, it's gonna have an oil and mist all on the side of it. You don't want to do that. Alright, when I put this picture up, I kinda laughed at myself, because I was like, okay, say you're this guy, and your engine died. Do you want a vacuum pump, or do you want a Venturi? I was like, vacuum pumps are so much better. And I'm like, well, define engine died, right? Because if it stops spinning, I want a Venturi. I want a Venturi now as I work my way down through the clouds. Now the gyros, they'll stay spinning for a little while, but not very long. So I laughed at myself because I was like, well actually, Venturis don't sound so bad after all, right?
Wouldn't you have like a lot of cost for icing? Venturi?
Yeah, you're probably not
If
gonna
it's
have a Venturi
cloud.
in a plane that, back to, nobody that's flying IFR is gonna have a Venturi. They're gonna have a vacuum pump. So, this isn't coming through good. I put in here, and you can look at it on your own time, I'm gonna go through it fast. I said, this guy's dead, he just doesn't know it yet. He is descending at 1,400 foot a minute. He's, maybe 1,500 foot off sea level. So, he's turning left with his nose down. The very interesting part, he's doing 95 knots. Why, if your engine's dead, and his engine's dead, because I don't have any fuel flow, I don't have any EGT temperature, what else was the engine dead for?
Probably got full flaps,
Full flaps, why's that?
because he's descending at 1,500.
He better not have full flaps and above flap speed. Mechanics are gonna be mad at
He
him.
better not be going 1,500 foot per minute descent rate, too.
Well, so this guy's dead, he just doesn't know it yet. So the pilots in here will go, yeah, if I lose my engine, I'm not gonna fly at 95, I'm gonna go to best fly, which is usually closer to 75 in a Cessna 172, which is what this is. So, and interesting though, is he's still got 27 volts. What are you smart electricians? So what's happening in the airplane? Anybody? Prop's still spinning. We're still spinning the alternator, right? If I got, so that was interesting. At least my prop's still spinning, which means my vacuum pump's probably still running. So that's good news. So as long as your engine doesn't seize, well, your vacuum pump is engine driven. So as long as your engine's not seized, as long as it's still going around, your vacuum pump should still be running. Yeah, Randall.
If your prop's windmilling, will your alternator actually keep up with all your electrical system?
Depends what all your means, and it depends on the windmill speed. But yeah, they windmill at 1200 RPM, something like that. So you're going to be right in that gray area. You're probably not going to want to, use all your electrical, stay on the radio,
In an emergency.
but it'll make a little power. It'll make a little power.
I think
All right.
you
Did I even change the slide? I don't think I changed the slide. So, all right. Anyway, I looked it up and I was like, oh, he survived, because I saw a flight they did later, and then I looked at it later and I was like, oh, it was a sim flight they just used to. So it turns out the guy wasn't almost dead. Is somebody was flying in a simulator and took a screenshot. So fortunately, because I was like, how did we get that picture? That guy should have died. It was a sim flight, but pretty realistic looking sim flight with that instrument panel, isn't it? Alright. Twin engine planes are usually going to have those two independent vacuum systems. One vacuum pump on each engine, and the pilot will have a VSI, not VSI, pilot will have an attitude indicator, turn coordinator, all that stuff. The co-pilot will have his own. So the idea is if one engine dies, stops running, the other engine will power the other pilot's instruments, so at least you don't lose all of them. So, and that's back to when you said there was that selector valve. Sometimes you got a valve for if one engine dies, you can make both instruments run, but anyway, crisscross. This one shows, it says, the gate check valve, when we talked about, used to prevent vacuum system damage from engine backfire. And you're like, how is the pressure gonna, is it coming back through the oil separator? Or is it engine kickback? But it's interesting. That was about all the clues that they gave me on why that back check valve is. And Shane's like, I have no idea what you're talking about, because he just showed up. All right. Alright, I already talked about that stuff. Next slide to break. Notice, like you guys have been talking about, there is no negative on any of those numbers. So on our suction gauge, it's only positive. We normally measure inches mercury, and pretty much the sweet spot's usually right at that 5.3. But it is measuring a pressure difference between the vacuum pump or venturi and cabin after the air filter, but it is typically a negative is what we would think of the pressure difference being. Because of that, last thing before the break that you do need to know, if you were to go in an airplane that's using a vacuum pump, so typically reciprocating engine, because once we get into jet aircraft with turbines and all that kind of stuff, most of this, what we're talking about vacuum system, is like, well, we'll do something else. If you go really, really, really high, like the bombers in World War II high, not a pressurized aircraft yet, and your engine's out there in very thin air, it's very hard to get even a 5-inch difference, because let's say you're at like 20,000 feet, we only have like 15 inches PSIA, if you will, or HGA. So it can be very difficult for a vacuum pump system to work when the air is super, super thin. So there were some aircraft that flew very high that they would switch their pump around and they would push pressurized air into the instruments, because even if it's really thin air, well, as long as you run your pump enough, you will build pressure, right? So some high altitude aircraft did use the positive side of the vacuum. It's not a vacuum pump then, the pneumatics pump, that's weird.
Air mover?
The air mover, but it was, the compressor, they would make it a compressor. It was rare, you'll probably never see those, but they have a question tied in there like, why would they do that? Why would they do that? Because it's so rare. And the answer to why would they do that is super high, the air is thin, it's hard to get enough vacuum pressure just by sucking, because you're sucking against almost nothing, hard to get that kind of a pressure difference. So that's why they would do that. Other than that, it's a terrible idea because of dirt and stuff like that. I need to take a break.
So why would an aircraft that flies super high use
Use the positive pressure off the pump.
positive pressure off the pump?
Yeah, because it's hard to get enough negative pressure.
Okay, thank you.
I wonder what happens if I push this freeze button. I gotta get better at that freeze button. Oh. Alright, I didn't say what time to come back at. Make it 5:02, that's a 10-minute break. Fortunately, we only have about 6 slides that count, and then we got about 15 slides that are just for funs and giggles. Yeah, I'm a float plane guy. I got float plane slides. One's a video. Woo! Ooh, you're gonna love the video. Or you're gonna have nightmares. It's one or the other. Love it, nightmares.
Oh, yeah. Is it always like that? Yeah. What did you have?
A little bit of both. A little bit of both. Love the nightmares.
What you said? Yeah.
I was sent down to Texas to get half drowned.
This year's Super Bowl?
There's your clue.
And where they flip you upside down? You have the nose, the water go through your nose and get out of it. Yeah. I didn't.
It was fun. It was a fun day.
I thought I heard every day that he was.
Yeah, he did.
Yeah, okay. I was gonna return.
Yeah, all our American pilots go through that training.
Really? I mean, it makes sense. The screening class.
It kind of makes sense.
They took it to that extent a week ago.
Yeah, it kind of makes sense. They actually say,
I knew it still worked, but I couldn't see.
we want you to go through the training so you realize nobody's getting out of this.
Yeah.
Like, I don't think they put that on paper, but like verbally, that's why we go through the training. It's like, you know, there's probably a safety order that says you should go through this. But if everybody in the back of your plane, yeah, don't flip the plane.
Turn on UND, they had us going to chamber. Like 40,000.
We did that in flight departments.
Yeah?
We didn't go as high as you, I don't think. But
Where do they do that?
we did ours, Dr. Pennell had a chamber set up at Western Michigan University. Is that Battle Creek?
Kalamazoo.
Kalamazoo.
The airport's in Battle Creek.
Battle Creek. I was gonna say, I always use back. I heard flight departments in Battle Creek.
I got pretty good.
I didn't notice anything. My fingernails changed a little.
And I was thinking.
It was me and one other guy. The other guy, oh, there's 5 of us, but me, there's 6. Me and the other guy, I couldn't tell. He was fine.
Yeah.
Like, the problem is when you do it with a group,
If you're watching everyone.
they gotta shut it down when the sensitive folk get bad. So me and the other guy, we were like, let's keep going. They said I was a little bit, I don't know if giggly's the word, but they noticed I was a little off. I did not notice I was off. So that was good testing because it was a reminder of, I'm probably not gonna notice. Like, I just won't know. Where the other guys, did they do cards with you?
Okay.
So they did the cards with us, where they have a deck of cards and they say name the card. And I think it was Dustin Ish, if he's flying Rain or no. And he's doing good with the cards, and he got to a certain card, and he just kept saying the same one over and over. They're showing him new cards. And I'm sitting there, fairly coherent. I'm like, dude, you can't. fine motor skill, like running a nut onto a bolt. And I think they noticed for me, it took me a while to get it.
Might not be a hard training pad or
Yeah.
a restock.
I thought I was doing fine, but. Nice. He called it 11:55? Okay. Will do. Oh.
Sean Ryan style way better than Peter.
Boy, I don't know.
It's like about yeah, he's Joe Rogan's just more like he's a lot more about learning.
Yeah,
I
he's
just
pretty
wrote
Joe Rogan's so like he's so like he gets so many different people to like sometimes
Rogan, like you're not getting Donald Trump on the Sean Ryan show, but
That's true, yeah.
did.
Rogan can reach so many.
He did.
Sean Ryan got Donald Trump.
Yeah.
No way.
You did not see that episode?
No, I don't.
That was probably the most scripted episode of all time. It was broadcast history.
Well, I mean,
Trump gives the same answer for
Well, he can, because he can only, you're allowed to, you're only allowed to ask him certain questions.
no lie. This is a lot more serious, so I don't know.
Yeah,
He could be a little bit more chill sometimes. But the other thing is,
I just got this.
he's very like.
I read it. Yeah. There's no comedy. There's no comedy.
Zero.
Which is I don't mind that because
Depending on the subject.
Alright, 10 seconds and we're rolling.
I used to watch them all.
let's do it. Yeah. I get that's fair.
Alright, we're in.
So that's all I would do.
Is that unfreeze? Whoa. Alright, we're back. Done with our break. Digital instruments. I actually was going through your exam today. Hello? Hello? I see you guys. Where is everybody? Okay, well, what happens when you show up late? I was going through your exam today. To make it easy on you, and I wanted to give you some notes of things you'll miss. Our digital instruments. Way back in the day, they had things like a symbol generator. So think like a black box thing, maybe like GPS-ish or where other airplanes are, and they got to figure out where to put the triangle that's the other airplanes. And it might not have been a digital screen. They might like project that onto the screen you're looking at. So they used to call that a symbol generator. It was basically the computer that would like project stuff onto the screen. I can't think of any instruments that I've seen that use that kind of technology anymore, but some of the prepware questions kind of still show up. So symbol generator. Nowadays, we're gonna have EFIS, electronic flight information, I think system is what it is. And basically digital. So we go to digital. You got an LCD display, liquid crystal digital, or LED display. They're going to be a digital signal. So some of the terms we have, a symbol generator was like back in the day, and it's like, I got to put something on their screen. Well, nowadays it's in a computer. You're not really going to see that, but that's what a symbol generator is. And EFIS is, think glass panel, and basically everything gets converted to digital, so it's going to send a digital signal. There is a question that one of the answers they try to give you is a carrier wave signal. They're like, does an EFIS use a digital signal or a carrier wave signal? I'm like, carrier, what is that? So, you guys actually know the answer to this one. Does anybody know what a carrier wave signal is, or what's a carrier wave? Radio. There you go. So remember when we had my guitar up here and I went, pwong, and that pwong was, it's not giving any info, but it's just our pwong, and we'll adjust our pwong by either changing the frequency slightly, FM, or by changing our amplitude slightly, pwong. Well, that's not right, you get the idea. Most of our aviation is what? AM, right? So the carrier wave is just the pwong that doesn't really give you any information. So they're just trying to they're trying to throw you for a loop if they say an EFIS uses a carrier wave, because the carrier wave is what your communications radio is, just the baseline it sends out to say, from here we'll change something to put information on it, right? So EFIS, digital signal for dealing with what you got going.
What does EFIS stand for?
I just said that. Were you out of the room?
I think I came a minute.
You should come on time. It's in Dale Crane's book. Electronic flight information, I think, system. Yes, glass panel, glass panel.
Wait, if you go
Alright.
back to your slide, it's
So this picture's a what?
if the S is system, what's the system?
Somebody look it up.
No,
EFIS.
I'm just
No,
saying
it-
your slide.
This slide.
I looked it up this morning because of, what?
Electronic flight instrument systems.
So it's one extra S, kind of like our bit test. Should be a bit test. But, yeah, it is. Okay, this picture came in fuzzy, and I was like, actually, I kind of like it fuzzy because it was back to when I didn't like glass panels. Because I'm like, man, you gotta be staring right at that thing to read it. If you had analog gauges, you can get it out of the corner of your eye, right? But I did then clear up the picture a little bit and be like, wow, that's some pretty good situational awareness once you go to an EFIS. Once you go to a digital panel in front of us, you actually don't even have to look out the window. You could like fly off that thing. It's got all your engine monitors on there and co-pilots. Oh man, they're nice stuff. So all that stuff is digital and part of the EFIS. Yeah.
Two kind of related questions. Up in the middle there, he has a heading indicator instead of a compass.
That might actually be a vertical compass.
Oh, okay.
Yeah, because legally he'd have to have a compass, which tells me that must be a compass.
Yeah, that was my second question. Do you still legally have to?
Yeah. Now, I haven't seen those a lot. I'm not 100% sure. That might even be a slaved one. I'm not sure. No,
The
because the
Skyhawk
slave
guy
one would have to be a
probably has
backup
one
on
like
top
that.
of it, right? Because you need a real compass in the cockpit in case everything goes wrong. When everything goes wrong, you need a compass to look at. That's the idea. All right, a lot to look at. Basically, as you fly fancier and fancier aircraft, they teach you how to read these screens. So we can't cover that in a half hour lecture. But warning lights pop up. You get a big red X over the instruments that aren't working, right? Don't trust that. Before you had the LCD screens, you know, the cockpit looked a little bit more like this. And this guy probably had a symbol generator that pop up onto him. But anyway, they'd look a little bit more like this, and if it looked like this, you'd have a ton of warning lights. It's kind of like in our Beechjet and our other ones. And when those warning lights pop up to tell you, hey, there's a problem. So if your panel ever looked like that, you'd go, oh, I got lots of problems. Or you're in test mode, because most of them have, you know, when you fire it up, they'll turn every light on to make sure the light bulbs work. So I'm assuming they're in test mode, because if they're not in test mode, they got problems going on, right? All right, so what we're going to cover is not necessarily all of the position indicators, not even close, but just the idea behind them. Big one is our angle of attack sensors. So we're going to cover our stall warning horn, which is like either you're almost stalling or you're not aerodynamically. Most newer and fancier airplanes take it a couple steps further, and they'll say, hey, we're going to give you an angle of attack sensor to say, am I nowhere near stall? Am I halfway there, so be careful? Am I stalled? You better put the nose back down, right? So they'll give it to you in various lights. I'm not going to teach you what all the lights mean, but you guys know green is good, yellow is be careful, red is, hey, you got a problem, buddy, right? In order to do this, we're going to need some sensors to be able to figure out where we're at. Old school instruments, they might just have the flags on the gyros or light bulbs to give you an indicator, right? All right, so a couple of the sensors that we have, our Beechjet, I believe, has these slotted probe angle of attack sensors. It'll look a little bit more like this one. If you look really close on the Beechjet, there's two slots in there. Basically, the way it works is our air is coming along the side of the airplane, or however you want to phrase it, and if the air is coming more from the bottom of the airplane to try to fill in this slot more, that slot is routed through the mast into this pressure chamber. So you're going to have one pressure going into that slot if it's coming from below, and another pressure coming into this one. That would fill this pressure chamber. So if this pressure chamber were higher than this pressure chamber, it's going to rotate. So it actually rotates the little mast so that it's lined up with the airflow going across the side of it. So when you're walking by the Beechjet next time, go find that thing and just gently turn it, and you'll be like, whoa, it's one of those really expensive high-tech devices that's just fun to turn. Because you're like, there's some engineering here, right? Nice bearings, fun to turn. So these act exactly exactly the same as what this would, that kind of makes sense, right? It's just a vein out in the wind, and it's gonna align itself with the wind. These slotted probes, they do the exact same thing. It's just the air pressure coming into them gets funneled into one of two compartments on the inside, and that'll turn the inside to line up with the airflow. So that will turn, and then obviously it would have to be connected to some sort of sensor or system that will relay that information back into the cockpit and or the flight computer to tell you what angle is the air going by the airplane, to tell it, hey, are we gonna stall because my airflow is on this angle compared to the wing, and it can't be that much. So, everybody tracking with me on that one? Kinda cool. The old school version were this is what you're gonna see on more of our Cessnas and mission aircraft. There we are. This one's just an electrical switch. I'm trying to remember which way it goes. I think it goes this way. So it's mounted on the front of the wing, and basically the way to think of it is when that switch is down, everything's fine. We're all happy. If I had this on the wing, if I tip the wing up into the air coming into the wing, the air is then gonna push that switch up, which is gonna set off a horn to say, you got too much of an angle of attack of the wind going to the wing. Now, if the wing's perfectly level, but you're falling out of the sky, the relative airflow still pushes the switch up, right? So, if you had this on an aircraft, and it's mounted on the front of there, and if your stall warning horn was going off too early, that basically means this is mounted too high on the wing, and it's getting pushed too early, right? So you would have to go in, there's usually a set of screws that hold it in place, and they'll either be slotted on here so you can move this, or it'll be slotted on the aircraft. But so basically you can move this up or down the leading edge of the wing to say, hey, when do I want the stall warning horn to go off? Every airframe manual will have that in the service bulletin, or service manual, excuse me, to tell you how to adjust it, because there's gonna be a specific number of knots. Typically it is 5 to 10 knots before the wing actually stalls, is when they want the horn to go off. So if a pilot were to say to you, hey, my stall horn is not going off, I just fall out of the sky and die. Well, I mean, I'm up doing air work and my horn doesn't go off, and you walk up to it and you go, well, the horn works, it must be mounted in the wrong spot. Okay, if your horn's not going off, it's probably too low on the wing, so let's move it up a 1/4 inch, and we'll go out, we'll do a test flight, we'll see when the stall happens, and hopefully it goes about 5-10 knots before it stalls. Make sense? If he was saying, man, my stall horn goes off constantly, I can't even do a landing without that thing going, and I'm not flying that slow. Well, this thing must be mounted too high on the wing, so now I gotta move it down on the wing so that it doesn't go off as early. The vane type, this is not a vane type, is this, wait a minute.
You're holding up vein, you're pointing at a
Reed, that's right, vane type, excuse me, let's call it vane because it's got a little vein that sticks out into the airflow. The reed type, thank you. Do you play woodwinds?
Yeah.
I knew it. So, if you're used to woodwind instruments like a saxophone or a clarinet or a baritone or something.
bass clarinet.
Yeah, see, I was on to him. Where the part you blow in, where it goes, it has a little reed in it, right? Now, those ones you blow into and they go off. On our airplane, they're the opposite. They don't go off when you're blowing into them. They just, because they have air going into them. But if you suck on this thing, it'll go off. It's like sucking a bug in. I'm having trauma coming all back again. Because a lot of the manuals will tell you to put a rag over that before you suck on it to test it. Because if there is a bug in there, it's a thing. I can feel it. I can still feel the bug in my throat.
It actually happens?
Oh yeah. When I'm pre-flighting as a pilot, one of my favorite things to do is go up to this beautiful airplane, this beautiful girl, and give her a big kiss. You go right up to the wing, and it goes, and you're like, good, my stall horn works. Now, that's the other reason to use a rag if you're flying one of Smat's planes. I've been kissing that thing the same thing on the vane type.
Okay.
Well, because you have to use tongue and it looks a little funny.
Oh!
Right? It's just, so you only do that. You only do that. Next time I do one, I'm gonna. It'd be the greatest Facebook post ever. The guy's like test. I think I've seen it. I bet if you look it up, somebody's testing their stall horn. But anyway, you suck on it. So basically the same thing with this, right? Is as you get on the top of the wing. If I draw the whole wing, there's the bottom. That's a funny wing. So the vane is in here, and when the airflow comes forward through it, out to the stall warning horn, when the airflow comes out, it's gonna go off, right? So if we put that hole anywhere on the bottom side of our wing, that's the pressure trying to lift our airplane into the air, and the air goes through the stall warning horn and it does not go off. But if we move that opening up high enough, and to exaggerate, now let's say it's way up here, well, we're trying to lift our airplane, so we have very low pressure there, so the air comes from the inside of the wing out the stall warning horn, and that's why it makes the noise, right? So if you got a reed type, and it's going off too early, well, that means it's mounted too high, and you better put it down lower. If it's going off too late, so the stall warning horn's just not going off, that means, well, it's mounted too low, it's always getting positive pressure, so you gotta move it up the wing. So, go look at a wing, you can test them out. Do we even have that many wings? You can test them out there. I might recommend cleaning the wing with alcohol or using a rag, because, well, I already told you how I test them. So, that's what you get. Questions, comments on those? Okay. The Cirrus SR22 and others, they just have a pressure switch that's mounted basically on the wing, one of your homework things. And I can't remember, I never worked on a Cirrus. So I can't remember if that pressure switch is up here or up in the front. I don't know. You guys probably don't even know either. You did all the homework and you don't even know where the pressure switch port is. I did the same homework with you too. But basically the idea is if it gets low enough pressure, it's going to go off. So I think it's going to be mounted somewhere in the front as well. It's going to be the same idea. Is if you get in a stalled attitude, it'll be a negative pressure. So I think it's mounted up towards the front section. But some of y'all will write on there, I'm going to put the aircraft in a stalled attitude. And I'm not saying you guys, I'm saying last year's students. I said, okay, did you do that in the hangar? And they're like, yeah. And I'm like, So they basically jacked the airplane up. At least that's what they said they did. And I was like, no, you gotta test fly it. So if you're doing that homework and SR22, if you didn't test fly the aircraft after you adjusted the stall horn, you did it wrong, right? So I'm gonna have to go grade some of yours. Probably some of you are like, oh, that's right, I should have test flown it. So that's your kind of big clue there. You gotta test fly a Cirrus after you adjust the stall horn, because it's basically measuring the pressure trying to escape from the wing. Very similar to a reed type valve. It's just using a pressure instead of a horn that goes.
You gotta go back to general on the angle of attack.
Exactly. Yeah. Okay. Some of them. This is just an indicator for your flaps. Some of us are, when we look out the window, we can't tell. Is that 10 degrees or 20 degrees? I can't tell. SMAT actually takes a magic marker. It's kind of cool, and they'll put a line on there. When they're down at 10, it meets the line. Oh, it's nice. But if you're in a big aircraft and the wings are behind you because you're the pilot up front, you can't even see the flaps. So a really big aircraft, they'll have an indicator there to say, hey, where are your flaps actually at? Now, if you're smart and you're flying a SMAT Cessna, they do have a little white line that moves by where the flaps are. So you could just look there. But our SOPs say visually check. Make sure that's not just the cable down, the flaps actually went down. All right. Last little bit before we have some fun and dismiss. What is that a symbol of?
Speaker.
Sound, speaker, yeah. So basically your stall horn, right? So in instrument class, you might have pressure switches and your engine pressure. You might have any sort of thing that would be considered an instrument, but you can't see it, right? So So we're in this kind of gray area, you're like, I can't see that, is that an instrument? I'm like, yes, but it gives an oral warning. So I've got some slides here for you, and, we're gonna,
Oh, that's not good.
let's watch that.
He's about to be sorry.
Where's my,
Case, is that when you hit the stump?
That's right.
When the stump hit you.
so in a float plane, if you land wheels down, that's why you will flip it. When the wheels hit, there's so much drag. Basically what happens is the wheels produce drag, they tip your nose of the aircraft down, and once the front of the floats hit, it's all over. So that will happen every time you land wheels down. So I have some more slides for you. I have some more slides. You're gonna try to notice what we see in common with all these news reports of float planes that ended up upside down in the water. Ooh. That one's hard to tell. Those might be up.
The nose wheel.
Yeah. Hard to tell. Mid-crash. Yeah, tone 'em in.
Wait, go back.
Yeah, you have the PowerPoint on your computer.
No.
Huh,
Oh, man.
what happened there?
Wheels up.
Wheels up. No. You know, lest you think you should always land your aircraft with the wheels up. Not on the pavement. So, our landing gear indicator usually is an instrument system, right? It's a position indicating system to tell you, is your gear up, is your gear down? So, landing gear position sensors are gonna somewhat fit in our instrument class to tell you. You haven't had prop class yet, right? When you look at props, you can actually tell from a picture like this. This one's a little trickier, but you can actually tell if they were under power or not. Like, was the engine running? Was the engine not running? Randall, you got a question or a comment?
I was gonna say, where do we draw the line of instruments we can take apart? It's like a flap indicator you can take apart, can you?
Depends what flap indicator. The little white thing by the flap, I don't know if I'd call that an instrument. On my landing gear, you're not allowed inside the box. So basically, if it's a box, if it's a sealed box, you ain't going in there.
Even if it's just a box of lights.
Basically, yeah. And back to, if you have info, maybe that manufacturer gives you the info for it. No, we're gonna blur the lines, but pretty much if it's a box, you're not going inside. Mr. Ward,
How does that little white thing work
what white thing?
for the Cessna's flaps system?
It's actually tied to a cable in the flaps, and they run a whole cable back into there. So when the flaps are down, there's a cable that moves to pull it. Didn't we cover that in airframe? So we slightly covered our flap system in that what actually turns the flaps on and off is micro switches there. And when you push flaps down, you've moved it and you've tripped one of the micro switches, and then you don't touch the switch again. So the flaps start moving, and connected to that little white indicator, there's stuff back there. And when that white thing moves far enough, it then, I think the word would be opens. It reopens the circuit to the flap motor.
That's all in the,
It's all right behind your little panel there.
that's, we didn't know that.
Yeah, so,
But
yep.
we can't work in that.
Yeah, that you can. It's not inside a box. That's just, yeah. So that flap indicator would not be a instrument, but the little one would. All right, so kind of fun. This one I think they have feathered, but it must have been, I don't know, rotating a little bit weird. If they're curled forward, the engine was under power. Like we got power to it, my understanding. Try to remember this from Christina's class. But basically, picture it's trying to dig itself through the air, and as soon as it hits the runway, the tip of that prop is going to want to pull itself forward, because it's trying to go forwards. If they curl backwards, it was not under power, because you basically just ran the prop into the ground. It'll bend backwards. So, interesting, when you see damaged props, you can be like, was that the bad engine that wasn't running, or was that the one pulling me across the ground? So, I think that's how it works, but I don't teach the class, so remember it for later. Randall.
So if SMAT draws flap indicators on the window,
It's not on the window. It's, these guys. Okay, so, where is it? No. I had one, didn't I? No, it's the little, it was on the left. There, you're not allowed inside here, right? But, when it's the switch, you'd be allowed inside the switch. All right, I think that's it. Let's go to live. Yeah.